I want to talk about another software design concept, encapsulation. Encapsulation is the notion of restricting direct access to an object's fields. This way, you can expose a public set of methods that modify the private internal fields, and you can control the exact ways outside classes can and can't manipulate these internal fields. Now, the opposite of this would be having fields that are just completely publicly editable, meaning that any external class could modify these fields any way that they want. This makes it easier to introduce bugs because you can basically do anything to the fields from anywhere in the application code. It also makes hunting down these bugs a lot harder since it's possible that some random external class was at fault. Right now, I'm in GameViewModel, and with this ViewModel's live data, we're in this exact situation. I'm going to go over to Project and open up the game fragment. And then basically from anywhere in here, I could get the view model, and then get a live data for the view model, such as the score, and I could change its value. Now architecturally, this is a big no-no, because the fragment isn't supposed to do any sort of data processing or data changing. The fact that I can type this statement at all is a problem, and it points to the fact that our live data is not properly encapsulated. So as a general rule of thumb, you should try to restrict edit access to your live data. In this case, only the view model should be updating the score and word fields. But for this observation code to work, it's important that you can still get some access to the live data, so it can't be completely private. Let's go back to our game view model. So being able to write and read from live data is where the distinction between mutable live data and just plain old live data comes in. Mutable live data is, as the name implies, live data that can be mutated or modified. Whereas live data, on the other hand, is live data that you can read but you cannot call setValue on. So here inside the view model, we want the live data to be mutable live data, but outside the view model in, say, game fragment, we want the mutable live data to only be exposed as live data. To do that, we can use a concept in Kotlin known as a backing property. A backing property allows you to return something from a getter other than the exact object. Here's how this will all work. In the code, I'm going to make two versions of this score live data object. One that is mutable and will be used internally, and one that is not. For the internal version, I'm going to use mutable, and I'm going to put an underscore in front of it. I'm also going to mark it as private, because it's private to the view model. Now for the external version, I'm not going to make it private, and I'm going to call it score, and I'm going to make its type live data instead of mutable live data. This right now is public. I'm now going to override this public live data's get method using a backing property, and I'm going to return the internal score. Because of this type that I specify here, this is only going to be exposed externally as live data, meaning that if I go over to my game fragment, suddenly this is treated as live data and I don't have access to this setter anymore, which is what I wanted, so let's go ahead and delete this code now. Let's go back into the game view model. There's a few things I'm going to need to update. If I scroll down, I now want to change the score to the internal version, so I'll go through and I'll put underscores in front of anywhere that I reference score. This now means that I'm using the internal version, which remember is the mutable version, which is why I can still call setValue. Okay, so I've properly encapsulated my score live data. What I want you to do is go up and encapsulate the word live data as well. When you're done, make sure to run your app. Good luck!